Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to discuss about the topic alligation and mixture in the form of percentages. Okay, actually this is the second part of alligation and mixture. If you haven't watched the first part, I recommend you to please watch first part of the alligation and mixture, so that you can come to know what is the concept of alligation and mixture and also what are the methods we use to solve the problems. Okay, now in this video, we are going to discuss about the alligation and mixture in the form of percentage. Okay, in the first video we discussed alligation and mixture when it is given in the form of ratios. Okay, but in this video we will discuss when it is given in the form of percentages. Okay, first of all I will explain you alligation and mixture in the form of percentages by taking some examples, and then we can move to the some basic level problems. Okay, now consider suppose there is a vessel here. Okay, suppose consider there is a vessel here. Now in this vessel there is a mixture containing milk and water. Okay, suppose consider there is a vessel here. Now in this vessel there is a mixture, and in that mixture is combination of milk and water. Okay, now they are telling that okay, in this vessel the percentage of water is 20%. Okay, the percentage of water is 20% in this vessel. Now how can we write this percentage in the form of ratios? Okay, see here, suppose the entire mixture is a combination of milk and water, right? Now they are saying that the water percentage is 20%. Okay, now water percentage is 20%. Now what is the percentage remaining? See here, out of 100%, water percentage is 20%. Now milk percentage is automatically 80%, right? Out of 100%, water percentage is 20%. Now what is the percent remaining? That is 80%. Now automatically milk percentage will be 80%. Okay, now how can we write 21s and 24s? So milk and water ratio is 4:1. Okay, now we can say this milk and water ratio is 4:1. Okay, in the same way I will take another example so that you can come to know when it is given in the form of percentage how to calculate total quantity of the water or milk. Okay, now I consider another example. Okay, suppose there is a vessel here. This vessel contains 50 liters of milk and water. Okay, suppose this vessel contains 50 liters of milk and water mixture. Okay, this vessel is mixture of milk and water, and the total mixture is 50 liters. Okay, now they are saying that out of 50 liters the percentage of water is 50%. Okay, the percentage of water is 50% here. Now how can we write this 50% into the ratio, that is milk and water? Okay, here the percentage of water is 50%. Now what is the percent remaining out of 100%? Okay, out of 100%, the percentage of water is 50%. Now what is the percentage remaining? 50%. So the milk percentage will be 50%. Okay, now if I cancel this, they are in the ratio of 1:1. Okay, so if I calculate this, milk is 1 part and water is 1 part. So there are totally 2 parts in this 50 liters. Okay, see here, after calculating percentages and converting them into the ratios, I will came to know milk ratio is 1 part and water ratio is 1 part. So there are totally 2 parts in this 50 liters. Okay, 2 parts in this 50 liters. Now what is the value of water quantity? See, water quantity is only 1 part, right? So there are totally 2 parts here. So 2 parts is 50 liters. What is the value of 1 part? That is water, right? So if I cross multiply this, I will get 50 by 2, right? So 2 ones 225. So water quantity is 25 liters in this 50 liters. Okay. Now this is the example where it is not given the total quantity of the vessel. Okay. They only given percentage of the water. But here they have also given what is the total quantity of the mixture, that is milk and water mixture. Okay. Now through that total quantity I came to know what is the quantity of water and also what is the quantity of milk here. Okay. And then now this is the basic concept actually behind the percentages. Whenever it is given in the form of percentages, we need to convert it into ratio. Okay. So after converting into ratio, we will follow the same method that we followed in the first tutorial to solve the problems. Okay, actually the solving methods are same in percentage and also ratios method, but only thing is when it is given in the form of percentages, we need to convert the percentages into the ratios, and then we can follow the same methods that we discussed in the previous part of the tutorial. Okay, now let's solve some basic level problems so that you can understand how to use this concept to solve the problems. Okay, now let's see the first problem. They are saying that a mixture of milk and water measures 60 liters. It contains 20% water. How many liters of water should be added so that water may be 25%? So we need to find out how much water need to be added so that water becomes 25%. Okay, now they are saying that a mixture contains total of 60 liters. Okay, and also they are saying that water is 20%. So water is 20%. Now what is the percent remaining? That is 80%, right? Now this 80% is equal to the milk of quantity. Okay, so they have given that 20% is water. So what is the percentage remaining? That is 80%. Now this 80% will be milk quantity in this 60 liters. Okay, now if I cancel this, I will get 21 24, so I will get 4:1. Okay, so there are totally 4 plus 1, that is totally 5 parts in this 60 liters. Okay, now milk quantity is only 4 parts. So out of 5 parts, milk quantity is 4 parts. 4 by 5 into 60. So we will get 5 ones, 5 12s. That is 12 fours 48. So there are totally 48 liters of milk in the total 60 liters. And also the quantity of water is only 1 part. Okay, so 1 by 5 into 60. So we will get 5 ones, 5 12s. So 1 into 12, that is 12 liters of water. So there are totally 48 liters of milk and also 12 liters of water in this 60 liters. Okay, now they are saying that how many liters need to be added so that water becomes 25%. 25% in the sense, okay, water becomes 25%. Now what is the percent remaining? That is 75%. So milk ratio need to be 75% and water ratio needs to be 25%. So we will get 25 ones, 25 threes, that is 3:1 ratio. So the new ratio is 3:1 and old ratio is 4:1. Okay, now we need to know how many liters of water need to be added to get this 25%. Okay, so I will get 48, initially there are 48 liters and 12 liters in this total 60 liters. Now they are saying how many liters of water need to be added. So I am considering liters of water as X here. So we will get the new ratio as 3:1. Okay, now if I cross multiply this, I will get 48 equal to 12 3 is 36, 36 plus 3x. So 3x will be 48 minus 36, that is 12 here. Okay, 3x equal to 12 and x equal to 12 by 3, that is 4 liters. So 4 liters of water need to be added so that the new ratio becomes 3:1. Okay, this is the answer here. Now let's solve the same problem using this units or parts method. See, they are given the initial quantity of mixture is 60 liters, right? So in this initial quantity, the percentage of water is 20%. Okay. Now what is the percentage remaining? That is 80%, right? So this 80% is equal to remaining part, that is milk. Okay. Now if I cancel this, 21s, 24s, that is 4:1. Okay. So the initial quantity is 4:1 in the ratio of 4:1. Okay, now they are saying that we need to add some liters of water. Okay, we don't know how many liters of water need to be added. So I am considering it as X liters. So after adding X liters of water, the new ratio becomes such that the percentage of water will be 25%. Okay, so if it is 25%, what is the remaining percent? That is 75%. So milk ratio is 75%. So if I cancel this, 25 ones, 25 threes. So the new ratio is 3:1. Okay, here we are adding only some liters of water. Okay, but we are not adding any liters of milk to the quantity. Okay, even though we are not adding any liters of milk, the ratio of milk is changing in both the cases, that is case 1 and case 2. Okay, see this, understand this. See, here we are adding some liters of water to the entire quantity. Okay, so we are not adding any quantity of milk to the quantity. Okay, we are not adding any quantity of milk to this mixture. Then the quantity of milk needs to be same in the first scenario and also second scenario. Okay, before adding X liters and after adding X liters, the quantity of milk needs to be same because we are not adding any quantity and also we are not removing any milk from the total mixture. Okay, but here the total ratio of milk is changing in both the cases. So we need to equate this, that is we need to make the both the cases as same ratio of milk. Okay, how can we equate this? That is 4 3 LCM, that is 4 LCM of 4 and 3, that is 12 units. So this 12 units, I want to make this 4 has 12. So I need to multiply the entire ratio into 3. Okay, I want to make this 3 as 12. So I need to multiply the entire ratio with 4. So I will get 4 3 is 12 and 3 1 is 3. 4 3 is 12 and 4 1 is 4. So here we made the quantity of milk same in the both cases. Okay, see this, I hope you are understanding. See this, we are adding some liters of water to the entire 60 liters. Okay, so since we are adding water to the quantity of water in the mixture before adding and after adding will be changed. But we are not adding any quantity of milk to the total 60 liters. Okay, since we are not adding any quantity of milk to the mixture, the quantity of milk before adding and after adding needs to be same in both the cases. That's what we are doing here. We are equating both the cases such that the ratio of milk needs to be same in one case and also second case. Okay, now what is the change here? That is, quantity of water is changed here. Now this change is happened due to adding of x liters of water. Okay, now if we see here, this is the initial ratio now, this is the final ratio now. Okay, this is the initial ratio and this is the final ratio now. Okay, now in the initial ratio there are totally 12 plus 3, that is 15 parts. So we already know that the initial quantity in the vessel is 60 liters of mixture. Okay, now this 15 parts is equal to 60 liters of mixture. Okay, I hope you are getting my point. See here, initially there are totally 12:3, that is 12 plus 3 is 15 parts. So this 15 parts is equal to 60 liters of mixture because the initial quantity is 60 liters in the total vessel. Okay, now 15 parts is equal to 60 liters of mixture. Now what is the change here? That is 3 minus 4, that is only one part is changing in both the cases. Okay, after adding x liters of water, one part is changing in both the cases of water. Okay, after adding x liters of water, only one part is changing in both the cases of water. Now this one part equal to x liters, right? This one part happened due to adding of x liters of water. So this part is directly related to x liters of water. Now we need to find out what is this one part value. Okay, we already know 15 parts value, that is 15 parts is 60 liters. Now what is the value of one part? That is one part equal to x liters. So if I cross multiply this, I will get 1 into 60 by 15. X equal to 1 into 60 by 15, that is 15 ones 15 fours, that is 4 liters of water. Okay, understand this. I have explained the same concept in the previous tutorial also, but now I am explaining you once again. See here, we are adding some liters of water to the total mixture, that is 60 liters. Okay, but we are not adding any liters of milk to the quantity. Okay, since we are not adding any liters of milk to the quantity, the milk in the first scenario and also second scenario needs to be same. Okay, so but here it is changing in the first case and also second case. So we need to equate the total ratio of milk in the first case and also second case. How can we equate them? By taking LCM of ratio of milk, that is 4 and 3. The LCM of 4 and 3 is 12. So if I need to make this 4 as 12. So I am multiplying the total ratio as 3 into 3. Okay, I am multiplying this total ratio as 4 so that I can come to know this 3 as 12. Okay, so that's the reason I got initial ratio as 12:3 and also final ratio is 12:4. Now the quantity of milk before adding the water and after adding the water is same in the both cases, right? So the only quantity of water is changing, that is how much part is changing, that is 3 minus 4, that is 1 part. Okay, we already know 15 parts is equal to 60 liters of mixture. Now what is the value of one part? That is 60 by 15, that is only 4 liters of water. So if we add 4 liters of water to this 60 liters, I will get 25% as water in this 60 liters. Okay. Now let's solve the same question using this option verification method. See here, the options he provided is A, that is 6 liters, and B 4 liters, C, that is 2 liters, D, that is 10 liters, and E is none. Okay. Now see here, they are telling the total amount of mixture initially is 60 liters. Okay. Now in this 60 liters, the amount of water is 20%. Okay, 20%. Now what is the percent remaining? That is 80%, right? So 80% will be milk ratio. So we will get 21s, 24s, that is 4:1. Now in this 60 liters, there are totally 4 plus 1, that is 5 parts. Okay, the ratio is 4:1. So there are totally 4 plus 1, that is 5 parts. in this 60 liters. Okay, now what is the quantity of water? So that out of 5 parts, the water quantity is only 1 part into 60. We will get 60, 5 ones, 5 12s. 12 liters of water in the initial mixture. So initially the total quantity of water is 12 liters in the 60 liters. Now they are saying that we are adding some liters of water. Now after adding some liters of water, the total quantity of water changes to 25% of water in the final mixture. Okay, so what is the percentage remaining? That is 75%. Okay, 25 ones, 25 threes. So the final ratio will be 3:1. Okay, see here, in the initially the quantity of water is 12 liters. So to this 12 liters we are adding some liters of water. Now after adding some liters of water, we are getting the final ratio as 3:1. Now see here, the question is very interesting. I will tell you how to solve this. See here, initially 12 liters of water. Okay, now we will add some quantity of water to the quantity. So we will get final quantity of water in the entire solution. Now that final quantity of water needs to be exactly divisible by 1 part. Because in the 3:1, that is final ratio, the quantity of water is only 1 part. Okay, now whatever the quantity of water we will get finally, the quantity of water needs to be exactly divisible by 1 part. Okay, now see here initially 12 liters. Okay, now whatever the option you add to this 12 liters, all options will be exactly divisible by 1 part. Okay, see here, I hope you are understanding. Initially 12 liters of water. Okay, we will add some quantity of water. Now we will get final quantity of water. That final quantity of water need to be exactly divisible by 1 part, because in the final ratio the quantity of water is only 1 part. Okay, in the same way 12 liters of water, no matter whatever the option you add to this 12 liters, all the options will be exactly divisible by 1. Okay, see here, suppose I will add 6 liters. So I will get 12 plus 6, that is 18 liters. 18 liters will be exactly divisible by 1, because 1 can divide any number, right? So 1 can divide any number. So if I add 4 liters to this 12 liters, I will get 16 liters. Okay, now this 16 liters also exactly divisible by 1 part. Okay, now how to solve this in this kind of questions? See here, the initial ratio is 4:1, final ratio is 3:1, right? So we are adding only some liters of water, right? So we are not adding any liters of milk to the quantity. So initial ratio and also final ratio of milk needs to be same in both the cases, same as the units or parts method. Okay, here the initial ratio and final ratio of milk, that is needs to be same, because we are not adding any quantity of milk to the entire solution. We are adding only some liters of water. So the quantity of water is changing here, but the quantity of milk is same in first and second case, right? So we need to equate the first and second case of milk quantity. So how to equate this? By taking LCM, right? As we are solving in units or parts method, the same method is applied here. See here, 4 and 3 LCM is 12 parts, right? So to make this 4 as 12, I am multiplying all ratio with 3. And to make this 3 as 12 parts, I am multiplying all ratio with 4. Okay, so I will get 12 is to 3 ones 3 and 12 is to 4 ones 4. So here the amount of quantity of milk is same in both the cases. Only quantity of water is changing. So what is the total quantity of water in the final ratio? That is 4 parts, right? In the final quantity of mixture, the ratio is 4 parts, that is quantity of water. Okay, now to this 12 liters, if I add any of these options, I will get some quantity of water, that is final quantity of water in the mixture. Now that final quantity of water needs to be exactly divisible by 4. Okay, now let's see here, this is 12 liters, I am adding 6 liters, 12 plus 6, I will get, that is 18. 18 is not exactly divisible by 4, and then I am adding 4 liters, 12 plus 4, I will get 16, 16 by 4, 16 by 4, that is we will get 4, exactly divisible by 4, and then I am adding 2 liters here, 12 plus 2, I will get 14 liters, 14 by 4, so it is not exactly divisible by 4, and then 10 liters, 12 plus 10, that is 22 liters by 4, 4 not exactly divisible by 4. So the only option that is exactly divisible by 4 is 12 plus 4, that is second option. So 4 liters is the answer. Okay, in this kind of problems we need to equate whatever the quantity that is not changing in both the cases. Okay, whatever the quantity that is changing, we need to multiply this and also find out what is the solution. Okay, whatever the quantity is not changing, we need to equate the same quantity in first and second case. Okay, same as units or parts method. Okay, only this kind of situation occurs only when there is one ratio. In the both ratios we will get one part. That's the only situation we will face this problem. In other problems we can simply solve the problem using this option verification method. Okay, now let's see the second question. They are saying that 50 grams of an alloy of gold and silver contains 80% gold. The quantity of gold that is to be mixed with this alloy so that it may contain 95% gold. So we need to find out what is the quantity of gold that needs to be combined so that the total quantity becomes 95% of gold. Okay, now they are saying that initially there is 50 grams of total quantity. Okay, so the total mixture is 50 grams. Now in this total mixture the quantity of gold is 80%. So what is the percent remaining? That is 20%. So 20% will be silver and 80% will be gold. Now if I cancel this I will get 21s 24. So the total mixture is in the ratio of 4:1. So there are totally 4 plus 1, that is 5 parts in this 50 grams. Okay, there are totally 4 plus 1, that is 5 parts in the 50 grams. So what is the quantity of gold? That is out of 5 parts the quantity of gold is 4 parts into 50. So I will get 5 ones 5 tens 40 grams of gold. So in the same way I will get what is the total quantity of silver, that is 1 by 5 into 50. 5 ones 5 tens. So 10 grams of silver. So in this 50 grams 40 grams of gold and also 10 grams of silver. Okay, now they are saying that to this mixture some grams of gold needs to be added such that the total quantity will become 95% gold. Okay, 95% gold. Now what is the percent remaining? That is 5%. Okay, so here to this mixture we need to add some grams of gold so that it contains 95% of the gold. Okay, now what is the percent remaining? That is 5%, right? So if I cancel this I will get 5 ones 5 19 5 95, yeah, 19. So the total ratio of gold and silver in the final quantity is 19:1. So they are saying that some grams of gold needs to be added. So I will write entire data in the form of equation. So I will get, this is 40 grams, right? 40 grams by 10 grams. We are adding some grams of gold. That is, we don't know how many grams. So I am assuming it as x grams. Okay, we are adding x grams of gold to this 40 grams so that the final ratio becomes 19/9. Okay, if I cross multiply this I will get 40 plus x equal to 19 times 190. Okay, now x equal to 190 minus 40, that is 150. So 150 grams needs to be added so that the total ratio becomes 95% of the gold in the final mixture. Okay, now let's solve the same problem using this units or parts method. See here, initially the total quantity of mixture is 50 grams. Okay, initially the total quantity of mixture is 50 grams. Now in this 50 grams the total quantity of gold is 80%. Okay, the total quantity of gold is 80%. Now what is the percent remaining? That is 20% is silver. Okay, now if I cancel this I will get 21s 24s. So the total ratio is 4:1. Okay, now they are saying that after adding some grams of gold the final ratio becomes 95% of gold. Okay, now what is the percent remaining? That is 5%. So if I cancel this I will get 5 ones 5 19 5 95, yeah, 19. So I will get 19:1. Okay, see here, after adding some grams of gold, so we are getting the total quantity of gold as 95%. So what is the percent remaining? That is 5%. So 5% is equal to silver and 95% is equal to gold. So if I cancel this I will get 5 ones 5 90, that is 19:1. Now here we are adding only some grams of gold. Okay, so we are not adding any quantity of silver to the total mixture. Okay, then the initial quantity of silver and also final quantity of silver needs to be same in both the cases. Okay, see this, understand this. Here we are adding only some grams of gold. We don't know how many grams of gold is added. Okay, now we are not adding any grams of silver to the total mixture. Since we are not adding any quantity of silver to the mixture, the quantity of silver in the first case and also second case, that is before adding and after adding, needs to be same. That is, in the first case and second case the quantity of silver needs to be same. Okay, now see here whether the quantity is same or not. See here, in the first case the quantity of silver is 1 part. In the second case also the quantity of silver is 1 part. So the quantity of silver is not changed in the both cases. Okay, now there is no need to equate in the both parts. Okay, if the quantity is different, then we can equate the both the cases so that the quantity of silver needs to be same in both the cases. Okay, now here it is already same, so we don't want to equate these two parts, right? Okay, now the only difference is here 14 and 9, that is some grams of gold. Okay, here the difference is 19 minus 4, that is 15 parts is total difference. Now this 15 parts of difference occurred due to adding of some grams of gold. Okay, we don't know how many grams of gold. Now we also know that the initial quantity is 50 grams. Okay, the initial quantity is 50 grams. That is, the initial ratio of gold and silver is 4:1, that is 4 plus 1, totally 5 parts. Okay, now this 5 parts is equal to 50 grams. Then what is the value of 15 parts? Okay, understand this. Initially the total quantity is 50 grams. We also know that the initial ratio of gold and silver is 4:1, that is 5 parts. Okay, now this 5 parts is equal to 50 grams, right? So 5 parts is equal to 50 grams. Now we need to find out the difference, that is 4 parts and also 19 parts. The difference is 15 parts. Now to find out this 15 parts value, I am cross multiplying the parts. So I will get 15 into 50 by 5. So we will get 5 ones, 5 tens, 15 tens, 150. So 150 grams of gold needs to be added so that the final quantity of gold becomes 95%. Okay, I will explain you the problem once again. See here. Here the initial quantity is 4:1. So the initial quantity is 50 grams. It is already given in the question. So this 4 plus 1, that is 5 parts, is equal to 50 grams. Now they are saying that after adding some grams of gold, that is we don't know how many grams of gold. So after adding some grams of gold, the total gold quantity becomes 95%. So the ratio is 19:1. Okay. Now we are adding only some part of gold. We are not adding any part of silver to the total mixture. So the quantity of silver in the first quantity and also second quantity needs to be same. So here the quantity of silver is same in both the cases. So we don't want to equate them. Okay. Now the difference is only 19 parts and 4 parts. That is totally 15 parts is different here. So this 15 parts difference occurred due to addition of some parts of gold. Okay. We don't know what is the some grams of gold. So I have already know 5 parts is equal to 50 grams. Now we need to know what is the value of 15 parts. So 15 parts is equal to 150 grams. So if I add 150 grams to the initial quantity, I will get 95% of gold. Okay. Now let's see how to solve the same problem using this option verification method. See, the options he provided is, okay, A is 200 grams, okay, and B is 150 grams, C is 50 grams, and D is 10 grams, and E is none. So we need to solve the problem using this option verification method. So initially the total quantity is 50 grams, right? Initially the total quantity is 50 grams. Now we already know what is the percentage of gold in this 50 grams, that is 80%. So 80 is to 20. The ratio of gold and silver is 80 is to 20. So we will get 21s, 24s, that is 4:1 ratio. So there are totally 4 plus 1, that is 5 parts. Okay, there are 5 parts in this 50 grams. So what is the quantity of gold? That is out of 5 parts, gold quantity is 4 into 50. We will get 5 ones, 5 tens equal to 40 grams. So in this 50 grams, the quantity of gold is 40 grams. Okay. Now we need to know after adding some grams of gold, the total quantity becomes 95% as gold. Okay. After adding some grams of gold, the total quantity becomes 95%. So the remaining percent is 5%. So if I cancel this 5 ones, 5 90s. So the final ratio is 19:1. Okay. So the initial quantity is 40 grams. So if we add some grams of gold to this 40 grams, the total quantity becomes 95% of the gold. That is 19 ratio. Okay, 19:1. So the final quantity needs to be divisible by 19. Okay, see here, after adding some grams of gold, we will get what is the final quantity of gold. So that final quantity of gold needs to be divisible by this 19, because in this gold and silver ratio, the ratio of gold is 19 parts. Okay, so the answer needs to be divisible by 19. Okay, now I will add all the values to the 40 and let's see which is divisible by 19 here. Okay, I will add first value, that is 40 plus 200. So I will get 240 grams. 240 needs to be divisible by 19. So 19 19 once 19 and there will be 5 here 50. 50 is not exactly divisible by 90. So this is not the answer. And again B value, that is 150 grams. So I will get 40 plus 150. I will get 190 by 19. So 190 by 19, that is 19 ones 19 cents. So this is exactly divisible by 19. And let's see C value, that is 50. 50 plus 150. Sorry, 40 plus 50. Okay, 40 plus, to this 40 grams I am adding 50 grams. Okay, I will get 40 plus 50, that is 90. 90 by 19. So 90 is exactly not divisible by 19. So this is not the answer. And D is, that is 10 grams. So 40 plus 10. So we will get 50, and 50 is not exactly divisible by 19. Okay, so this is not the answer. So only B is divisible by 19. That is, B is the answer. Okay. Now let's see the third problem. They are saying that 100 liters of mixture contain 20% of water and the rest is milk. The amount of milk that must be added so that the resulting mixture contains 87.5% milk. So we need to find out what is the quantity of milk that needs to be added such that the final quantity contains 87.5% milk. Okay. Now they are saying that the initial quantity, that is 100 liters of mixture. Now in this 100 liters of mixture, the percentage of water is 20%. Okay. Now what is the percent remaining? That is 80%. Okay. Now this 80% belongs to milk here. Okay. Out of 100%, 20% belongs to water. Now the remaining 80% will belongs to milk here. Okay. Now if I cancel this 21s, 24s, the total ratio of milk and water becomes 4:1. So 4:1, that is 4 plus 1. Total 5 parts in this 100 liters. Okay. There are totally 4 plus 1, that is 5 parts in this 100 liters. Okay. Now what is the quantity of milk in this 100 liters? That is, out of 5 parts, the milk quantity is 4 parts into 100 liters. So we will get 5 ones, 5 20s and 24s, 80 liters. 80 liters is the total quantity of milk in this 100 liters. In the same way, what is the quantity of milk? That is, out of 5 parts, milk quantity is 1 part into 100. So we will get 5 ones, 5 20s. So 20 liters of milk water in this 100 liters. Okay. Now they are saying that to this mixture we are adding some liters of milk such that the final quantity becomes, milk quantity becomes 87.5% and water becomes, what is the percent remaining after adding 87.5? What is the percent remaining? That is 12.5. Okay. After 87.5% gone, what is the percent remaining? That is 12.5. Okay. Now if I cancel this, 12.5 ones, 12.5 sevens. So I will get 7:1 is the ratio of milk is to water in the final quantity after adding some liters of milk. So we don't know what is the number of liters of milk. So I am considering it as X liters. Okay. Now I am writing all this data in the form of equation. So I will get to this 80 liters by 20 liters. I am adding X liters of milk. Okay. I am adding X liters of milk such that the final quantity becomes 7 by 1. Now if I cross multiply this, I will get 80 liters plus X equal to 27, that is 140 liters. So if I send this 80 liters to the right hand side, I will get X equal to 140 minus 80, that is 60 liters of milk. So 60 liters of milk needs to be added to the initial mixture such that the final quantity becomes 87.5 liters. Sorry, 87.5%. Okay. Now let's see how to solve the same problem using this units or parts method. See, initially they have given the total quantity is 100 liters. Okay, 100 liters. Now they are saying that the initial quantity of milk in the, water in the 100 liters is 20%. Okay, the initial quantity of water in the 100 liters is 20%. Now what is the percent remaining? That is 80%. 80% belongs to milk. Now if I cancel this, I will get 21s, 24s. So the total ratio is 4:1. Okay. Now 4:1 is equal to 100 liters. Okay. Now, and also they are saying that after adding some liters of milk, we don't know how many liters of milk, so I am assuming X liters. After adding X liters of milk, the total ratio of or total percentage of milk becomes 87.5. So what is the percent remaining in? That is 12.5%. So 12.5% belongs to water and 87.5% belongs to milk. Now if I cancel this, I will get 12.5 ones and 12.5 sevens. So we will get 7:1. Okay. We are adding some liters of milk to the mixture. We are not adding any liters of water to the mixture. So the quantity of water before adding and also after adding needs to be same in both the cases. Okay, see here in the first case and second case the quantity of water is same, that is only one part. Okay, see here we are adding only some liters of milk. We are not adding any liters of water to the quantity. So since we are not adding any liters of water to the quantity, the amount of water in the first case and second case, that is before adding and after adding, needs to be same. So here the quantity of water is already same here in the first case and also second case. So we don't want to equate them. Okay, here the quantity of water is already same in the first and second case. So we don't want to equate them again. Okay, now we will get the only difference is 4 and 7, that is only 3 parts. Okay, the difference is 7 minus 4. There are 3 parts difference in the milk. Okay, in the milk there is 3 parts difference. Now why this difference occurred? That is by adding x liters of milk. Okay, by adding x liters of milk, the difference of 3 parts occurred in these parts. Okay, now we already know what is the quantity of 100 liters, that is 5 parts. 5 parts is equal to 100 liters. Now what is the quantity of 3 parts? That is 3 parts equal to 3 into 100 by 5. So I will get 5 ones 5 20s 23 60. So 60 liters of milk needs to be added to convert this into 87.5%. Okay, now let's see how to solve the same problem using this option verification method. In the option verification method, the options they have given is 1 that is 30 liters and B that is 35 liters, C that is 60 liters and D that is 45 liters and E that is none. Okay, now the initial quantity they have mentioned is 100 liters of mixture. Okay, and also they have given that the total quantity of water in the total mixture is 20%. Now what is the percent remaining? That is 80%. So we will get 21s and 24s. So 4:1. There are totally 4 plus 1, that is 5 parts in this 100 liters. Okay, there are totally 4 plus 1, that is 5 parts in this 100 liters. Now what is the value of one part? One part value will be, that is 100 by 5, that is 5 ones 5 20s. So what is the quantity of milk? That is only 4 parts. Okay, so 20 into 4, that is 80 liters of milk in the 100 liters. Okay, now to this 80 liters, if I add some liters of milk, I will get the total quantity, that is in the new mixture there is 87.5% of milk and remaining 12.5% of water. Okay, now to this 80 liters of milk, if I add some liters of milk, I will get in the final quantity the percentage of milk is 87.5% and percentage of water will be 12.5%. Now if I cancel this, I will get 12.5 ones 12.5 sevens. So 7:1. So this is the total ratio of milk and water in the final quantity. Okay, now if I add this some liters of milk to this 80 liters, I will get final quantity of milk. So final quantity of milk is nothing but 7 parts here. Okay, now after getting final quantity, that final quantity needs to be divisible by 7. Okay, see this, understand this. See here the initial quantity of milk is 80 liters. So now to this 80 liters I will add some liters of milk. We don't know how many liters of milk, we need to find out from these values. Okay, after adding some liters of milk, I will get final quantity of milk. So here that final quantity of milk is nothing but 7 parts. So after getting final quantity, that final quantity needs to be divisible by 7 here. Okay, now I will substitute all the values so that you can understand. See here, to this 80 liters I am adding first value, that is 30 liters. 80 plus 30 we will get 110. So is 110 is divisible by 7? I think it is not exactly divisible. Okay, B is 80 liters plus 35 liters. So we will get 115 by 7. So 717 and 45. 45 is not divisible by 7. So this is not exactly divisible. And again C, that is 80 plus 60. We will get 140. So 140 by 7. So we will get 7172 40 and 0. This is exactly divisible by 7. Okay, so the third value is exactly divisible by 7. Now let's see fourth value, that is 80 plus fourth value, that is 45 liters. So we will get 125 liters, 125 by 7. I will get 7 ones, 7 and 55. 55 is not exactly divisible by 7. So this is also not exactly divisible by 7. So only option C, that is 60 liters, is exactly divisible by 7. So 60 liters is the answer. Okay, and try to solve more and more problems so that you can understand how to solve these problems in all the methods, and try to not depend only on this option verification method, because option verification method does not work in all the problems. Okay, there will be some problems where all the options will be satisfying the answer, so it will take more and more time to select which is the answer that is correct. Okay, that's the reason don't depend on option verification method, try to solve more problems based on this parts and also normal method. Okay, so that you can solve tough level questions also if you solve more problems based on this units and parts method. Okay, and that's it for this video. Try to solve more problems, and for more tutorials like this, please subscribe to the channel. Thank you.